Welcome to this Maths Made Easy video on the binomial distribution. To start with, let's discuss the factorial. Now the factorial of a number written as n with an exclamation mark here is equal to the following. So this is equal to n times n minus 1 times n minus 2, and this carries on all the way up here, times it by 3, times it by 2, and then finally times by 1. So for example here, 3 factorial is equal to 3 times by 2 times by 1 there. So 3 factorial would be equal to 6, for example. Now, n factorial is a number of ways you can arrange n objects. And you can picture this as having n choices for the first object, n minus 1 choices for the second object, n minus 2 choices for the third object, and so on. Okay, that gives us everything we need there for the factorial. Moving on now to discuss what happens if some objects are the same. Well, let's suppose we're arranging n objects and r of them are the same. So in any given arrangement we can swap 2 objects that are the same and end up with the same arrangement. Now here, if our objects are the same, then we can swap them into any order we like within the arrangement, and we will not have changed the arrangement. So in that case, there's r factorial such ways to swap our objects. And so the number of arrangements of n objects, r of which are the same, is simply defined as n factorial over r factorial there. Okay, so that there is for the number of arrangements of n objects, r of which are the same. So if we write that out here just so we can see this clearly, this is the number of arrangements of n objects, so number of arrangements here of n objects and r of which are the same. R of which are the same there. Okay, so that gives us everything we need there for discussing what happens if some objects are the same. Now let's discuss what happens if only 2 objects are different. So if we only have 2 different objects. Well, suppose we want to arrange n objects, r of which are of one type, and the remaining n minus r are of a second type. Well, we can arrange the r identical objects in r factorial ways, and the n minus r identical objects in n minus r factorial ways. So overall we have, if we write this out in full here, n factorial divided by r factorial times n minus r factorial. Okay, and this is the number of arrangements here. And this might look familiar, and you should recognise this as the binomial coefficient of n and r. So this is the binomial coefficient. This is the binomial coefficient of n and r here. Okay, remember we can write this as n choose r, so therefore n choose r, and we can also write this here as n cr. This is again equal to this formula of n factorial over r factorial times n minus r factorial there. Okay, so that gives us everything we need there for only 2 different objects. Moving on now to discuss the binomial distribution. And the binomial distribution tells us the probability of x successes from n independent events, where the probability of success for each event is p. And the probability function for the binomial distribution is given as follows. So let's say this is f of x, and this is equal to n choose x times p to the x times 1 minus p to the n minus x. Okay, and the way we understand this and how it works, well, the n choose x here is a number of possible ways to have x successes out of n events. And then what we do is we multiply this by the probability of x successes and n minus x failures, which gives us this formula here. And to discuss the notation here, if x is a binomial random variable with n trials and a success probability of p here, well, we'd write this distribution here for x as a binomial distribution, which we define using this b here, with our two parameters of n representing the number of trials and p being our probability parameter there. So that gives us everything we need there for the binomial distribution. Moving on now to binomial tables. Your formula booklet may contain binomial tables, and these give the cumulative distribution function value for the binomial distribution. So for example, if we want to find the probability of 2 or less successes out of 5 trials with a success probability of 0.15, well, using our tables here, again, like we can see, we've got n equals 5, our probability here, p, is 0.15, and we're looking for 2 or less then going across here, we can see the probability that we're looking for is 0.9734 there. So what this shows us then is that the probability of x being less than or equal to 2 is 0.9734 there. Okay. Now, if your formula booklet does not have binomial tables, you'll be expected to use the statistics function of your calculator to answer questions like this. Make sure you're familiar with how these work, as they will be necessary for any exams that you sit. So that gives us everything we need there for binomial tables. And finally, moving on now to when to use the binomial distribution, we just want to discuss the conditions that are required for a binomial distribution. So let's say we've got a random variable x. Well, if x is binomially distributed, we require the following conditions. So the first condition here is that there is a fixed number of trials. So we require a fixed number of trials. So let's write this out in full. Okay, so we have a fixed number of trials. The second condition we require here is that each trial has only 2 outcomes, success or failure. So each trial has only 2 outcomes. It has only 2 outcomes, and they are success or failure. So we write this out here, so that's success or failure. Okay. The third condition here is that the trials are independent of each other. So trials are independent of each other. They're independent of each other. Okay. The fourth condition we require here for when to use a binomial distribution is that the success probability is the same in each trial. So success probability is the same in each trial. Okay. And finally here, our final condition, condition 5, is that the random variable x is the total number of successes in all trials. So the random variable x here is the total number. This is the total number of successes in all trials. Okay. So that gives us everything we need there for when to use the binomial distribution. And that concludes this Maths Made Easy video on the binomial distribution.